Hello fellow skeptics, I'm Luther Name, and this is the fifth of the series of videos that I've produced on the general topic of, is there something wrong with modern physics, and if so, what can we do to fix it? Now, I decided I was going to give a little bit a review of the background of this series of videos that I'm producing. The first one is that I did not intend when I started the research to produce these videos. In fact, I was only doing it as a matter of personal interest. Once I discovered that there was an issue with using the center of mass and the orbital angular momentum, and then I looked into the gravity law, where clearly the center of mass, or the idea of the center of mass, was very important and prominent. Once I continued the research into the Newton's gravitational law and recognized that the general form of his law did produce a result that was similar to that Einstein had produced through general relativity. It was a perturbation on the orbital equation, and it was of the right order of magnitude to be similar to what Einstein had found with general relativity. Consequently, I found myself curious as to what else was going on within relativity, since even though special relativity, or the restricted theory, is no longer considered a standalone theory and has been subsumed into his general theory. He originally produced the general theory based on observations from his development in special relativity. So I looked into that. Of course, the natural consequence is, since I discovered and what this series of videos is about, is that there are issues with respect to relativity. It's used in quantum mechanics, and so the issue was, well, okay, are there other issues associated with quantum mechanics, since quantum electrodynamics does use special relativity, and if there are problems with special relativity, then they should be reflected in problems with quantum electrodynamics. So this is a transition video. Prior 4 videos were covering the topic of classical physics, or Newtonian physics. This is a transition into more modern physics. Now, for those who are interested, this book was written originally in 1923. It's a Dover publication. And this will show who was involved, or who the primary players were in developing relativity. It was done in 1923, so you'll know contemporaneously who was involved. And as Nobel laureate Steven Weinberg said, that, well, Einstein really completed relativity, and you'll see from this, the articles in this, and who the people were, that that's in fact what he did. He completed it. He added things to it, and so to speak, wrapped it up. But he didn't really wrap it up. There's also a paper in here by Hermann Minkowski, and Hermann Minkowski had taken Einstein's 1905 paper, which is also in here, and reformulated it using a more compact and sophisticated mathematics. And that's when people began accepting the idea of relativity, and that's in here too. And what's written in our textbooks is based on Minkowski's reformulation of special relativity. Now, what I did was, when I started the research, I took notes, and I created packets of notebooks, and when I finally realized I was going to be getting into relativity, I began to put the notes down in a more formal way. I used, or attempted to use, Richard Feynman's guidance, which is, if you can't explain something to whatever audience at whatever level it is that they would understand it, then maybe you don't understand yourself what you're trying to describe. So what I did was, when I finished with my research, I put together this book. It's really just kind of working notes, more formalization. You know, the whole reason for this was to get my thoughts in order and to put them down in a fashion that was reasonably organized and, from a conversational perspective, was understandable by the people I intended to read this. And this is fairly technical. Then when I proceeded to think about making the videos on the topics in this book, I was forced to rethink the audience that I was going to produce this material for. And so I again went through the process of trying to lay it out in a way that would be understandable to the audience. Now, in getting into modern physics from the classical, I showed how complicated some of the classical physics were, especially in Newton's general gravitational model. Well, it's even more complex when you get into relativity, but not necessarily in special relativity. In general relativity, it's complex to the point where it's almost impossible to describe anything mathematically. But with regard to the other material, you can go a long way with algebra. I've lost track of where advanced high school mathematics and calculus stops and where college calculus and algebra begins. But this is certainly, these series of videos are attempted to be presented at the level of first year college. Introduction, the people who are watching this are expected to at least know their algebra and maybe introductory calculus and some of the ideas associated with that level. Freshman, sophomore, but that's it. I didn't want to go any further than that. So with that, what I'm going to do now is speak to the transition that this video represents. It originally contained more information spanning into the beginnings of my discussion on relativity. But I decided to break that off, make this introduction, an introduction or a review of the introduction of what this whole series of videos is about, and then proceed to treat relativity and other modern physics then as a new set of videos dealing just with those ideas. Another reason for starting with Newton and the center of mass is that they're well understood concepts. There's really been no controversy around them. They're well described in our textbooks. So I wasn't dealing with an area that was unfamiliar to the majority of people who might see this video. The reason for starting there was that you can avoid a lot of controversy because everything that you needed to work with is in our textbooks. All I did was refine and take the next step in using what everyone should be familiar with, even in high school level physics. The reason for pursuing the Newtonian physics or at least another reason for pursuing it, is to establish credibility. If I could use or follow the techniques that I described and actually discover things that were unknown, new physics, it would help establish a credibility that as I moved on into modern physics, that I would have credibility. That when I supplied tools and descriptions to allow somebody to validate the work I was doing, then they would believe that I could also accomplish the same thing in moving on into relativity. Now, the issue with relativity is that there's a great deal of passion associated with it. Oftentimes more passion than knowledge. You either believe it or you don't believe it, and there's not really a strong underpinning to either belief. Certainly not from the perspective of being able to deal with the mathematics. As you'll see, people who purport to understand relativity don't understand it at all. And there have been other observations along that way that people who profess to have read Einstein's paper really haven't studied it. And they really have missed a great number of the things that are in there that are wrong. And as a result, there's been this body of so-called knowledge that's just flat out incorrect. And that's one of the things I'll show. So this is a slightly different topic when I get into modern physics, simply because there's a lot more a belief than knowledge, a matter of faith. We've been told things, but they aren't necessarily true. And there's a great deal of controversy ongoing right now with regard to things like quantum electrodynamics. There's a growing body of knowledge that says it's not only wrong, that the people who've been working in that area know it's wrong, but their careers are based on that. Same with relativity. Careers are on the line. If they have throughout their careers professed to understand it, believe it, and even use it in their work, well, they're in deep trouble if it's wrong. And as a result, there'll be a great deal of pushback against the technique is just to ignore it. And so I fully expect a great deal of what I'm talking about to be ignored. So with that, I'm going to stop and end this particular video. The next video will be on special relativity, and right out of the chute, I'm going to provide some information that's going to show that almost in the first pages of his paper, he was wrong and he made mistakes, and all the people who have professed to have read that paper will have missed all of these early warnings that there is an issue with whether or not special relativity even exists. So with that, this is Luther Name. Please leave comments. Whether you find this useful or believable, I'll be talking to you in the next video on special relativity, and I hope to prove to your satisfaction, as I have to my own, that it doesn't exist. Well, that's not quite true. Some parts of it do exist, but not all of it.